Okay, so we're back here with 9a, and we're trying to find the equation for a sphere that is inscribed in a cube. Before we do that, we're going to look at the two-dimensional analog for that. So that's why I have the circle inscribed in the square here. And if you look at this, if we have a circle inscribed in the square and they've got the same, that means that they're going to have the same center point. So in that case, that means that the center point is going to be the origin, and that the sphere is going to hit the walls of the circle is going to hit the walls, the center of the walls, each wall of the square, each side of the square. So we're going to get 1, 0, 0, -1 here, -1, 0, and 0, 1 as our side, or as the points of intersection between the circle and the square. So in this case, because our x0 and our y0 are both 0, and our radius is going to be equal to 1, because the distance between the center and 0, 1 is 1, we're going to get the equation for this is going to be x squared plus y squared is equal to 1 squared, or just 1. So my picture for when we're actually jumping up to the sphere case is a little bit less pretty, but we've got this sphere that's inscribed in this overarching, or this cube. So now it has a similar situation that is going to intersect the cube at the center points of each of these walls. So the center point right here, we're going to have to go over by 1, but it's still going to be 0, 0. It hasn't gone up at all in our z direction, and it hasn't gone down at all in our z direction, and it hasn't gone over in our y direction. It's just moved over in our x direction. So we have this as one of our points, which tells us that our r is going to be equal to 1. And we also, sorry, I should have said this first, it's still going to have the same center point as the cube that it's inscribed in. So that tells us that 0, 0, 0 is still going to be its center point. So that tells us we're just going to use x squared plus y squared plus z squared is equal to 1, because that is our x0, our y0, and